Just started. Go ahead. Give me that one more time. Give me that one more time. What did you just say? You heard that? You heard that, right? I'm not even joking. He said he went to bed black and woke up white. That's what this kid just said. Yo, you weren't around when I was a kid, obviously. You don't know nothing about Michael Jackson, but I'm just telling you. Listen, there's no, no, just stop. Okay, just stop. Like you can't. Just stop with this. You missed a lot. I'm just telling you. Okay, you just missed a lot. Can you just repeat it for him? Can you repeat it for him? He looks like he's having a day for a second. Go ahead, tell him. The kid went to bed black and woke up white, and I got video surveillance proof that says so right here. I'm not even joking. I'm not even. You want me for a tree? A tree? A tree? What are you talking about? You're crazy. So the visuals speak louder than words. It's emotion. All right. All right. Okay. So now, um, there was something we talked about like on the first day of class a little bit. We talked about like some stuff with polls, and we mentioned like if you start seeing, some sort of poll or something, and they start saying like 45% of the people said that they favored the candidate or something like that. And then we started saying like, oh, plus or minus, like they start saying 1%. Okay. Well, this thing, which is like sort of like the numbers between, 44% and 46%, right? So this is chapter 7, I think. This is on confidence intervals. All right, so then the first thing we want to talk about is this difference between like what is a point estimate and what is an interval estimate. Does anybody know or remember what any of those things meant? I think we said this the first day, but I'm not sure. Does anyone remember this? So point estimate is, do you have a guess? Go ahead. Like a range of numbers. Sort of, but the exact part is a little different, sort of. All right. So the what's the matter, Beyonce? Um. So what does a parameter mean first? Sort of like a property of the population, or like a no, no, something you calculated based off the entire population. So let's say we took, yeah, it could be the average, could be the median of the population, it could be the maximum number of the population, it could be the minimum number, it could be whatever statistic you were talking about. Does that make sense? All right. But it's not called a statistic anymore when it's on everything. Does that make sense? Right. So that's what we said at the beginning. And we're always attempting to estimate a parameter, right? That's always what we want to do. Does that make sense? What's the average, right? But we never have the entire thing. We only usually have a sample, and then we want to use that sample, and then we calculate a statistic, And then based off that statistic, then we're really hoping that statistic is going to be close to something that's the true parameter for the distribution. Is that correct? But depending on the sample, the statistic calculated may differ greatly from the population parameter. Does that make sense? Parameter, we just said that. So somebody say it again.
You said something about it's a measurement of the population.
Something that's calculated on all of the things that are involved in the entire population. In other words, on all possible cases. Does that make sense? So I'm not just taking the average of the people I see in the room, I'm taking the average of every single person, let's say at Broward College. Does that make sense? So then, or every person that's ever been to Broward College, or will ever be at Broward College, or whatever. Does that make sense? Well, no, what I just mentioned though is like, are you ever going to be able to determine every single person who's ever been at Broward College, will ever be at Broward College, is currently at Broward College, whatever? No, you're never going to be able to do that. Does that make sense? So then you can't. So we end up getting a sample, right? You randomly select a sample so that the sample ends up being something that you can actually use to calculate something on, right? And then you use that to try to guess what the overall parameter is. Does that make sense? The sample only will give you a statistic, we said, and population is parameters. All right, but that's chapter 1 or something. All right. So but the point is though, like you're trying to get like X bar or something, and you're trying to guess what mu actually is, but you don't actually have everything. Does that make sense? So depending on which sample you decide to get, you might not really get something that close to what actually mu is, right? When we talked about this a number of times, I think, right? Right, if we randomly selected people, I made up the example where I was saying, oh, well, I mean, I don't think it's very likely for this to happen, but it certainly is quite possible, okay? There's definitely at least 1,000 people that will vote for Trump, right? And then there's, you know, you randomly selected 1,000 people, you happen to get those 1,000 people, but don't forget there's of course way many more, right? Then yeah, they're all going to turn around and say that they're going to vote for Donald Trump. Of course, that's not representative of the overall population, but is it possible? And if you didn't have time to go and sample more things, because this was, let's say it was like, there's other cases where you start discussing these things and it becomes very obvious why this starts becoming like a major issue, all right? But let's say like, you know, someone has cancer and you're trying to test the drug on them. Well, obviously you're not going to test the cancer drug on someone who doesn't have cancer. Then a lot of these people are going to turn around and start telling you that they want the drug, but you can't give it to everybody. You have to randomly select these people. But now all of a sudden, all of these people really have certain conditions that are similar to each other. So is it really random? Not really. Does that make sense? And then you have cancer and you also have this other disease, which might be the thing that actually makes you pass away. Does that make sense? So if you pass away, was it because the drug didn't work? Was it because of the other disease? Was it because of, right? This starts getting more complicated. Does that make sense? My point is that you're still going to test it on these people because you have no one else to test it on. So then if it works on these people, you hope it's going to work on the rest of the people. But it might not. And I gave you an example of my mother, I think I told you, was in the hospital or whatever, and she had breast cancer. She ended up passing away from it years later. But at the beginning, she had stage 4 breast cancer, and she was told she was going to pass away. And she went to what is Weston over here, the hospital, Cleveland Clinic, whatever. And she was there with a few, it was her and these 3 black women. And they all had stage 2 cancer, and they all passed away, and she didn't. And it turned out it was because the drug that was tested for these types of people, for this particular type of cancer, was only tested on people that had similar types of genes as the ones that she has. European type genes. And it just so happened that this didn't work with all of the genes. Of course, nobody knew at the beginning. Do you know what I mean? But the point is that this is the way some of these things happen. And the problem is that if I don't have you included in my sample, well, then I'm not going to be able to say whether or not the drug works for your type of people or not. Does that make sense? So when you randomly select these things, you hope that they're going to be good, but maybe that's the only sample you can get, right? And if that's all you can get, that's what you're going to be using. Does that make sense? Because if we haven't diagnosed a particular type of person with this particular type of cancer yet, what are we going to do? Give you the cancer to see how the drug's going to work with you? No. You know what I mean? So like but the point I'm trying to make is that sometimes your sample could be bad. Does that make sense? Most of the time it won't be though, right? You're randomly selecting all these people, 1,000 people, right? You got a pretty damn good guess who the hell they are going to be saying for president. Does that make sense? Right? So then maybe you don't want to do that if it's like the whole country. But down here, if you went and grabbed 1,000 people randomly from down here, wherever the hell they were coming from, and then you start asking them, I'd say that's probably going to give you a pretty damn good answer, right? Okay. All right, but so since we just keep mentioning, do you have a question? Sorry. No, you didn't cut me off at all. But Kanye, bro, I don't Kanye. You sitting and telling me Kanye is running for president, Kanye is not running for president, Kanye, Kanye, like the only Kanye is like a really, really expensive like piece of gum on the floor. Okay, like the thing is like it's like it's there. I don't care. All right, he's got money though, but that's all I know. Okay, and if the dude wants to run for president or not run for president, I could care less. Yeah, I really could. But the no, it's just that like there's so many people in this world. Like I'd rather worry about somebody who actually matters. Like I don't feel like that dude matters. I don't know if he ever did, but I definitely don't matter anymore. So like, yeah, but like, bro, Mickey Mouse probably got like 80,000 votes. Like, go check it out. Mickey Mouse gets a lot of votes every year, and I'll take Mickey Mouse any day. All right, Mickey Mouse has the same birthday as me. I like Mickey Mouse. All right, so then anyway, but sorry. I don't know. When I was a kid, like I was when we went to Disney World, they said something one time, and I was like, "Yo, that's my birthday," and then they're like, they gave me something because they were like, "It's the same birthday as Mickey," and they're like, "Oh, you should come back." I was like, "Mommy, they told me that." I should come back to see Mickey, and then I made them drag me back there. Of course, those fuckers knew what they were doing. Anyway, but yeah. Disney manipulating kids since day one. You know what I mean? So like anyway, but they know what they're doing. All right, so you got me here, right? We know what we're talking about with this stuff. All right, so then let's just make up some stuff a little bit first before we move on to what this point estimate and interval estimate is first. All right, so then let's say let's say this first. All right, so point estimate is in a single number estimate for a parameter. Interval estimate is an interval of numbers estimating a parameter. All right. So then you were saying something about like more specific, less specific before, or something like that, right? And you were saying that the point estimate is like more specific. And I said to you, and I started making faces and stuff. So like the interval estimate is actually like somehow always better. Okay. Why is it always better? So for instance, say again. No, no. What does interval mean again? Before we move on. Sorry. Like if I say that you have a number line and I just say like you have like an A here and a B there, right? An interval is like all of the crap between A and B. Does that make sense? So it's like, oh, I see. So then this, like that's an example of an interval. Does that make sense? Point A to B could be equal to also, okay? For this class though, we're not gonna be making it equal. So I'm writing parentheses here to indicate those are not included. Does that make sense? All right. So then all right. So an interval is just a range of numbers. Is that correct? All right. So this is a range of numbers. These are the numbers from like 0.44 to 0.46. Is that correct? Right. All right. So this thing here, this first number I was writing, this thing is called a point estimate. This part here is called the margin of error. And then this is called an interval estimate. Okay. Yeah. Point estimate is like a one number guess for your answer. Interval estimate is a range of numbers that we're saying is a guess for the answer. Does that make sense? So the range of numbers is always going to tell me a little bit more information because it's always going to sort of have the point estimate there. Does that make sense? Does that make sense? Now, in this case, we added the same amount on both sides. We don't always do that. Does that make sense? All right. Do you get what I mean, though? Like the interval estimate's better? Does that make sense, guys? All right. So then what are we actually estimating here? So now there's a variable that they want us to kind of understand a little bit. So P, all right? P is the proportion of success. Is that correct? Right? Probability of some event happening. Right? Well, like this thing is a P, really. Is that correct? It's a proportion of the amount of people that would be, let's say, voting for the particular candidate. Is that right? So we're actually trying to estimate that. Is that right? Does that make sense? And then this here really actually means that this is 0.44 is less than P is less than 0.46, right? Does that make sense? So we're saying that the range of proportions we think for the people that favor this particular candidate is somewhere between 44 and 46%. Is that right? Do you understand why I'm saying that though? Do you understand why me saying the proportion is 45% is like ludicrous? Why? Can you explain, please? Yeah, ludicrous, like ridiculous, stupid, stuff like that. Sorry? Well, that's why I'm asking you. I'm saying it's stupid. Not because you should be aware of why necessarily at this point, but I'm asking, or I'm trying to force you to think the way I'm thinking, whether that's correct or not. But the thing is the in this case, right? I claim that by whatever process people did this by, me stating that the proportion of people that, let's say this was, voting for Donald Trump or something, whatever, right? Just as an example. So then if I say that the proportion of people that like Donald Trump or are going to vote for Donald Trump is 45%, I'm saying that this is kind of stupid, but saying it's between here and here somehow makes more sense. Why? Pretty much. Yeah, I'm asking why though. Yeah, but I'm asking why. I'm asking why am I saying this? Just because I say it, who cares? Go ahead. No. Yeah, but why am I saying that, like, based off of the sample? So we did this based off some sort of sample, right? I haven't explained how to calculate this yet. Well, we sort of did actually before, but I haven't explained everything about it yet. But that's what we have to go through in a second, okay? But why is this like somehow bad? Well, the interval has actually lives more room for her, right? This is not allowing any room for her. It's saying it has to be 45%. Is that correct? Yeah, but I'm asking why is that somehow bad? Yeah. Why though? How are you doing this in the first place? How is this ever coming about? How are you ever calculating any of this stuff? How are you coming up with this number? Okay, but how are you coming up with this number? How do you get 45%? How would this happen in real life? What would you have to do? Right. So let's say just vote for Trump, let's just say. Okay. So then, like, whether you vote for Trump or not, does that make sense? Okay. You have a sample of people is correct, right? And then what do you do then? You got to ask them who the hell they're going to vote for, right? They're going to say yes or no, right? And then I'm going to count how many of them say yes, right? And then divide by however many there were. Is that correct? Then we're going to get the percentage of people that want to vote for Donald Trump, right? But I'm saying that's still like bullshit slightly. Because the problem is that, like you were saying, this is just a sample, right? Right. And because this is just a sample, it's just representative of that group of people. Is that correct? So depending on which sample we start selecting, you're going to get different answers. Is that right? Does that make sense? So the point that I'm trying to make actually is that this is not what they call P. This is actually something that they refer to as P hat. Okay. So P hat is what we call the hat. Like, yeah, like a psychopath, like wears a hat, why you walk around some. Yeah, like that's what like the people that wear the white hats. So then the no, the people when you go to like an asylum. Like so they say this is an expression for people that when they're in an asylum or something like that, they wear these particular types of hats that they, this is the crazier people. Okay, so like anyway, it's an expression. All right, so the if you don't know the expression, it's not very useful. All right, so the estimated proportion. I'm scared to think what you were talking about though. Okay, so the estimated proportion. All right, so then like we write this thing P, and then they call this hat in math, whatever, but this is pronounced P hat. Let's just go with P hat. Okay, so then all right, this one, got it? All right, so then how would you calculate P hat? We say P hat is equal to X over N, where X is the number of successes, the number sampled, and is sample size, right? Does that make sense? All right, so really this thing is actually P hat. Does that make sense? That's just what you got for your dumb sample, right? Which hopefully you randomly selected them. Hopefully that worked out correctly. Does that make sense? Then this is saying here that I think that P is somewhere between here and here. Does that make sense? So it's just slightly more information because the problem is that we know this can't be the exact right answer necessarily. You have to, because we know that there has to be some variation that is possible due to the sample. Does that make sense? You get it? Okay. Does that make sense, guys? All right. So you get the idea of why you would need an interval estimate, right? Now, the thing is like anytime you'll see interval estimates written in lots of places and you'll see them write something like, oh, 45% of the people like Donald Trump. I always look at that. I'm like, whatever, dude. I don't care. You just pretty much told me you're a bullshit artist because you didn't give me an interval. You didn't tell me the sample size. You didn't tell me the confidence level. I haven't explained to you what confidence level means yet. Okay. But unless you provide me all of this information and how you actually chose to sample these people, right? I don't know what you're doing. And I don't believe you. Does that make sense? Yeah, maybe you just ask your friends, right? Maybe you just ask people that are going to favor your particular opinion. Maybe you ask people that are not really representative of the population in some way, and you don't even realize you're doing that. Does that make sense? I don't, people aren't doing things for nefarious reasons all the time. They just might not have sampled correctly. Does that make sense? So like I'm just giving you examples with the nefarious type perspective because then you can think of bad situations where people could do these types of things and then you would want to know. Does that make sense? Right? Racism, right? That's pretty much what people are doing all the time when they're either persecuting religion or discriminating based off race, gender, whatever. Does that make sense? That's what they're doing. They're biasing these things. Does that make sense? They're only sampling certain people. Is that correct? All right. But then I give you the example with the medicine stuff, and then it becomes very serious, right? Of course, it's serious with races also. But anyway, so like these proportions, right? So we're really getting these p hats. Does that make sense? But you don't know. This could have ended up being 100%. People said Donald Trump. This could be 0%. People said Donald Trump. Both of those are definitely wrong. Does that make sense? Right? You don't know. You just got one of them. Does that make sense? All right, but we have to take this thing and we have to somehow come up with an idea of how we're going to come up with this interval type estimate, and then also explain like what that means, what types of mistakes people make when they're interpreting these things. Does that make sense? Because this is one of the most misinterpreted things in all of statistics, except for the next thing we do. But this is one of the most misinterpreted things. They're closely related, actually. Hypothesis testing is the next couple of chapters we do, and this is confidence intervals. They're very, 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 very intertwined, and we'll actually be able to solve all the questions using both of them very soon. So we'll keep reviewing this. Okay. But the thing is like this gets frequently misinterpreted. All right. So I remember this election a few years ago with Hillary and Trump. Okay. I always use this example because I still can't believe this went on so often, how bad the mistakes these people made. All right. So if I'm just, sort of oversimplifying the results right now with what I'm talking about, but this is pretty much the same idea. All right. So I believe we talked about this on the first day as well. Okay. So let's say I say to you that the people that were voting for Hillary ended up having a confidence interval that was, let's just make up some numbers. Let's say 41% to 43%. And then the people voting for Donald Trump let's say was between 40% and 42.5%. Does that make sense? All right. Now, if these things were calculated more or less the same way, which they should, but we won't discuss exactly why, the center of these things will be more or less the point estimate. Does that make sense? Okay. But whatever the point estimate is, this first point estimate is going to be bigger than this one. Does that make sense? Does that make sense? So therefore, if you had to use the point estimate to select who's going to win the election, you would say, I guess, Hillary, right? Hillary has a higher point estimate at that time based off the polls. Does that make sense? But these things, what does this mean? This means the proportion of people favoring Hillary, we think, is somewhere between 41% and 43%. Of course, it might be wrong. We might have just gotten a shitty sample. Does that make sense? And then the proportion of Trump people is between 40% and 42.5%, right? Well, these things overlap. Again, I'm just simplifying these things so that we can make a point with this. All right. So Hillary is somewhere between, I'm saying, 41% and 43%. Is that correct? Trump is somewhere between 40% and 42.5%. Is that right? But like, I don't know where. Is that correct? We just got a sample, right? We don't know exactly what the number is. Is that right? It's somewhere between here and here. Is that correct? That's the amount of information we were able to provide. Does that make sense? All right. So then maybe Hillary is right here and maybe Trump is right there on election day. Does that make sense? Maybe we're completely wrong. And maybe Trump's all the way over there. Does that make sense? Maybe we got a bad sample for Trump. Does that make sense? All right. But the point is that it's certainly quite possible for Trump's people to be more than Hillary's people based off of these results. Is that right? Instead, the news started coming out and saying Hillary was going to win. I was like, yo, why are you lying? We don't know that. I was like, don't tell people that. They're not going to vote. Or you're going to be encouraging the other side to vote. Whatever it is, it doesn't matter, whichever one, I don't care. Does that make sense? But just interpret it correctly. Does that make sense? Don't tell people the wrong thing. But my point is if all these news stations and all these newspapers and all this stuff are doing this is how easy it is to make these mistakes. Does that make sense? All right, so we just have to talk about this a little bit to explain where it's coming from so that we can explain the interpretation so you don't make the wrong mistake. Oh, also, one other example that I always talk about with this that I think is kind of helpful. So my kid, I remember, still coughs all the time, but he was coughing when he was like 1 year old. And it was pretty bad. Like I remember he was like 103 fever, staying up at night. I had to hold him up at night. It was not going to sleep, whatever. Okay. So she says, go get medicine. I go to this doctor to go get medicine. This doctor is such garbage. So I go there and the doctor tells me, I'm like, give me something because the kid's not doing well. Like, I got to do something. And we had already gone before. They gave us nothing. Now we go then again, and then they give us something. So I go to Target afterwards, go to this pharmacy, go get the medicine. I start buying the medicine. All of a sudden, I'm at the cash register. They're like, insurance. Here's my insurance. They're like, oh, it's going to be $200. I was like, $200 for good Lord, that's a lot of money. And then I was like, what's the deal? Like, what am I paying for? Like, I've never had to pay before. What the hell am I paying for? And I'm like, well, maybe I should read the medicine I'm buying for my son, right? So then I finally look at it, and it says this thing on there, and I was like, oh, I know what that means. It's a steroid. And then I started reading the other one, and I was like, oh, I know what that means. It's a vasodilator, right? And I was like, oh, what is this? What are we doing here? These aren't medicines that I thought. This isn't going to heal him or anything like that, right? They're giving me steroids and stuff. I was like, okay, I know what the steroids is for. It's to reduce the inflammation and all this stuff that they think he's uncomfortable, whatever, right? I was like, all right. I was like, my dad's a doctor. I'll just ask him. Like, what's the deal? I was like, I'm not putting him on the juice. No Sammy Sosa diet. All right. So then then I start waiting for the pharmacist to give me the medicine. And while I'm waiting there, one of the bottles is sitting there and they have the little pamphlet on the side of the bottle, right? And I was like, I was wondering what this stuff is, whatever, I'll just read it. So it has these confidence intervals in there. It starts discussing confidence intervals of these particular studies that were done, worrying about side effects associated with the particular medication, right? They're like, oh, if your kid's 1 year old and you give this kid this medication and you follow the course of the medication, your kid will grow an average of 1 inch less than everybody else. And I was like, I don't think I'm going to give them the medication, right? My point is I'm able to get this immediately by just reading this thing. Does that make sense? And I feel like nobody would read it, first of all. And then second of all, I think most people that were even reading it wouldn't be able to tell you what it means at all. Does that make sense? And it takes 2 seconds to be able to read one of these things. Does that make sense? All case studies everywhere have something with this in them. Everywhere. So any type of report on any type of information should be having some sort of documentation containing information like this. Does that make sense? So this course is not really about these statistics. This is about you being able to read stuff later. Does that make sense? That's really what this is about. Okay? Because even the doctors should be reading these things. But what's scary to think is that doctors don't actually read this stuff sometimes. And then, or the doctor doesn't understand this. Does that make sense? How do they know what drug to give you? How do they know what whatever? Does that make sense? All right, but you got me with this?
You would say that, yes.
You would say that you would say it's inconclusive who's going to win. You would say,
You can say like,
I can say more stuff, but then only with like certain chances. There's a certain chance this will happen. There's a certain chance this will happen. Does that make sense? But even that isn't like 100% true because these are all based off samples. Does that make sense? So there's still not really. You get what I mean? Go ahead. But if these were separated completely from each other, and like one of them was like, if this was here, does that make sense?
yeah.
Now I'm like Hillary wins. Does that make sense? But that's what they mean. You get what I'm saying? So go ahead. There's always a chance that there's an error, but now the probability of that happening, we can actually state what that's going to be, and then that's not going to be as high. All right, and that brings up the next part actually. So that's a really good question. I mean, all these questions are good, but the thing is you're leading directly into the next part of what I have to talk about. So that means you're thinking about the right thing. Does that make sense? All right. So then the next thing that they'll always talk about. So then we said this a few times, but I haven't really ever said anything about it. But like, this is called the confidence interval. So then this is what the hell is this confidence thing? Does that make sense? Okay. So all right, so I'm going to be a jerk and ask some questions now without actually teaching you anything. But that's what you always do in math because you ask the questions to someone before we've gone over it to try to show someone what they're confused with. Does that make sense? And then once we do it, then you're like, oh, okay. And then hopefully you don't have to, you hopefully you remember it then. Does that make sense? All right. But I hate saying this, but if it's ever a physics in a math class and someone starts asking you questions like this, right? Whatever your natural intuition is, usually it's wrong. That's the whole reason why they have to teach you this stuff. Does that make sense? So you should usually just start guessing the exact opposite, and then you'll be correct. Does that make sense? Okay, but don't do that because I just want. But anyway, you get what I mean? Like the physics teacher won't go sit here and do the physics demo unless people are going to guess the wrong thing, right? You're going to guess the right thing, then what's the point? Everybody already knows. Does that make sense? So all right. So if I say to you, if you are more confident, and we haven't really 100% explained what this means at all. should your interval be wider or narrower? In other words, larger or smaller? So you said smaller, you said wider. Explain. Of course, if I'm asking the question, it has to be the other answer, right? So the thing is you're supposed to say narrower. Ah, I got you. Ha ha ha. Okay, so then no, but the thing is that it's because what do they mean by confident? Okay, you're right. If I'm like more confident about my estimate or something like that, that like sort of it would sort of get narrower. Okay, but the problem is that what they mean by confidence is that they're saying that because you got to remember what we're trying to do, right? We're trying to estimate the parameter. Is that correct? Right? Does that make sense? So now, if you are more confident about your estimate for a parameter, right? Would you be more confident if we said the parameter was between, let's say, 2 and 5, or zero and 10, let's say. Okay. Now the thing is that it's this one here because there's more chance that the parameter will actually fall between those two numbers. Does that make sense? Does that make sense? Right? If I say you have between $0 and $10 in your wallet, or I say you have between $2 and $5 in your wallet, right? No matter what, there's a better chance that it's going to be this is right. Does that make sense? Just because there's more numbers. Is that correct? Does that make sense? There's more room for error. There's more room for me guessing the wrong thing. Okay, that's true. Yes. Okay. The that's correct. But but just be careful because there's going to be certain notions of what we're talking about with error, etc. All right. So you got to make sure you understand what they're referring to. All right. But what you're talking about is like very identically related almost. Okay. They say dually related, but it's the same idea. Okay. So the all right. So now we just got to talk about some things here so we can start trying to come up with some ideas about how we're going to construct one of these things. All right. So then if we have so there's certain like confidence levels that we frequently talk about. So they'll say something like 90% confidence, 95% confidence, 99% confidence. We'll do more than this, but these are frequently ones that we have to do. Does that make sense? They're going to be so common that you're going to sort of know the answers and you're going to have to do them so many times in your homework that it's helpful just to sort of memorize them. Does that make sense? You don't have to because your calculator is always going to be able to give you the answer, but when you keep calculating the same stupid number over and over and over again, you just remember eventually. Does that make sense? So all right, so let's see if we can remember some stuff from last time a little bit. Okay. So if X is normally distributed with some mean and some standard deviation, right? Right? Then we said Z, which is just equal to the X minus the mean divided by the standard deviation, would also be normal, but it would have mean 0 and standard deviation 1. Is that correct? Right? And then we started saying something like, I could start solving this thing. Is that right? So if we say Z is equal to X minus the mean times the standard deviation, right? And then we want to sort of say what X is, okay? But we're not doing just a regular number anymore because we're taking the average of lots of things. Does that make sense? We're sampling all those people. Is that right? Does that make sense? So now X bar sigma over square root of n because the central limit theorem applies now. So then the thing is that central limit theorem said that the average would follow a normal distribution with mean mu and standard deviation sigma over square root of n if n was greater than 30. Is that correct? Does that make sense? So if we know that this thing is normally distributed, then we can start sort of solving for what the mean would have to be between. So if I multiply this by the denominator here, which really just means multiply by the standard deviation, we get this. Does that make sense? This is the difference between the sample mean and the population mean, which can sort of be considered as our error. Because if I start calculating the mean of the sample, and let's say the mean of the sample is 5 and the mean of the population is 2, well, then I'm off by 3. Is that right? Does that make sense? And then what does Z mean again? Yeah, what does that mean again? So Z is just really the number of standard deviations away from the mean. This is just the standard deviation. Is that correct? Does that make sense? So what this is saying then is that whatever the mean is, right? The difference between it and the sample average is going to be equal to this. But this is just the number of standard deviations away from the mean times the standard deviation. So then if I say to you, that let's say I want to be 95% confident. Now let's assume that we actually knew what the mean was. Does that make sense? If I knew what the mean was, right? And if I wanted to be 95% confident and I wanted to come up with some sort of confidence interval, which would contain the sample average, right? The sample average would be somewhere. Does that make sense? And there'd be some place here where 95% of that stuff would fall. Is that correct? Is that right? Then this position here would be a certain number of standard deviations away. And this position would be a certain number of standard deviations away. Is that right? If we took the mean and then added the standard deviation times the number of standard deviations, it would send us to there. And then if we took the mean and we subtracted whatever the number was necessary and then times the standard deviation, it would send us to there. Is that correct? Does that make sense? And then that would give us an interval. Is that correct? The only problem is that we don't actually know what the mean is. That was the whole point. Does that make sense? Does that make sense? But we're gonna know what that is. Is that right? So we want an interval for where the mean would fall. Does that make sense? So if we start guessing that this is the actual average and start guessing that the center is actually X bar, does that make sense? That's all you have from your sample. Is that right? The point estimate. Does that make sense? Then if we knew the distribution of X bar, oh, but wait a second, we do. Right? Then we would be able to come up with an interval here, which would state where we think the value should fall. Is that correct? Does that make sense? All right, so this thing here, this is called the margin of error. So the margin of error is equal to the number of standard deviations away from the mean times the standard deviation. The way we write a confidence interval is we write something like point estimate plus margin of error, point estimate minus margin of error. The only thing is these two margin of errors might not actually be the same thing. For a symmetric distribution, they are the same. Does that make sense? Does that make sense? You understand what I'm saying by this?
How do you get the margin?
You estimate it based off the sample. You estimate the samples, the standard deviation based off the sample. How do you get anything if you're not going to know it for the population? You estimate it based off the sample. That's all you ever have. Does that make sense? All right. And then as long as your sample was large enough and randomly selected, it's going to give you a damn good guess. Does that make sense? And then as you did it a couple times, you probably get even better guess.
But you only have the mean of the margin of error.
You'll never get the mean of the population. It's impossible. Are you ever going to know how many people voted for Donald Trump or will vote for Donald Trump? No, they're never going to go and vote. Does that make sense?
Like, why would I subtract from the
So, because you have to say that it could be smaller, it could be bigger, right? Why would you only add? All right. So then the thing is then the problem is we need to know what the standard deviation is in all these cases. We need to know how to be able to calculate this, the number of standard deviations away. Once we do that, though, we should actually be able to do this. Does that make sense? All right. So I was mentioning, though, that we wanted to talk about this for certain confidence levels, right? We actually already know how to do part of this with some of these confidence levels. All right. So if I say to you, critical z-score for confidence level alpha. All right. And then let's call this, or excuse me, let's say then that this is which we've already done this before, actually. Z alpha. Does that make sense? All right. What does Z alpha mean again? Do you remember? This is on your homework. And we did his example before. What did the alpha mean? Yeah. But in this case, it meant something slightly different. So this was the only time I said in the entire class that this is going to break the Beyonce law. This is the only time something's to the right. But Z alpha means critical z-score for confidence level alpha. This means the z-score for the position with area alpha to its right. In other words, Z alpha is the position that has alpha area over here. Does that make sense? So then yeah, whatever that area is alpha. Does that make sense? Some number. Does that make sense? Then, so like if I said 95% confident, for instance, right? This part is 95%. I said like 90% confidence. This part should be 90%. Is that correct? So Z alpha is like the critical z-score that we need for this particular region right here, right? So then we start saying that alpha, or actually alpha is not the level of significance. Alpha is actually the probability of what they call as a type 1 error. All right. So if I start saying that we think it's between here and here, what's the chances I'm going to be wrong? If this is 95% from here to here, what chances I'm going to be wrong? 5%, 2.5 on each side, 5%, right? Okay. So then this is 0.025 or whatever, 0.025. Is that correct? This region is referred to as the alpha region or alpha. Does that make sense? Does that make sense? So what's alpha in this case right here? Alpha is 5%, right? What's alpha in this case here? 10%. Does that make sense? Then this part over here, the book labels it as alpha over 2. Does that make sense? Does that make sense? So this position right here, we call it Z alpha over 2. Or this is the same thing as Z 0.05 over 2. Or this is the same thing as Z 0.025 because there's 0.025 to its right. Does that make sense? 2.5% to the right. Does that make sense? Does that make sense? So that would tell me though how many standard deviations I need to go from here to here. How would I figure out what that number is? How do I figure out what Z of 0.025 is? This is on your homework and we did it last time. 0.025. Yeah. How are you going to type in calculator? Inverse norm is correct. Inverse norm of what? How do I find out where this one is? Because I'm saying this is 0.025, so it's that position right there. Is that right? No. What does Beyonce say? So it's all of this crap. Does that make sense? So it's 0.975. Does that make sense? So then sometimes people also say that like 1 minus alpha is what we call the confidence level. This right here is 1 minus alpha. This is 1 minus alpha. So then this, if we calculate this right here, what do you get when you calculate this? Where? Final answer, you saying? Yeah, that's right. So then this right here, this is, what'd you get? 1.95. All right, does that make sense? Or sometimes people say, we just remember 1.96. This is approximately 1.96 standard deviations that way. Does that make sense? How would you figure out this position? How would I label it? What is this? Z of what? What would I write right here? No, what's the number that goes there? That's not 0.025. What goes here? What does this mean again? What does it mean though? When I write Z comma alpha or whatever, what does the alpha mean? It says it right here. Read it, come on. Sorry? What does that mean in terms of picture? What does the alpha mean? It says it right here. It says the Z score with area alpha to its right. Is that correct? So alpha is what? Alpha is the area to the right. Is that correct? So this position has what area to its right? 0.975. Is that correct? All right. The area to the right is 97.5%. Is that correct? Right? All right. So then this, how would you calculate this? Z of 0.975. That would be what? How do you calculate it? In normal what? What'd you say? Yep. And then what should the answer be? Is that right? Is that right though? Isn't that like the same thing you just said before? Does that sound right though? Yes. Why? Because this thing is symmetric. Does that make sense? It better be the same damn thing. Otherwise, we made some big mistake. Is that right? So then this is, so 1.95996, but negative. We have to go the other way. Is that right? Does that make sense? Any question with this? This should review the last chapter a lot. Does that make sense? All right. So you got me so far? All right. So then this one here, this position, alpha here is 10%. So this means this is 0.05. So therefore Z of 0.05. How would I calculate this? This is an norm of what? How do I calculate Z of 0.05? That's correct. 0.95. Good. So then this is going to give you what? Should this be smaller or larger than 1.96? Smaller is correct. It's got to be closer. Does that make sense? It's got to be less standard deviations to get to there. Is that right? What's the answer? No. Yeah, 1.6445. Does that make sense? Or 1.65 actually. There you go. It should be 1.645 though. That's what I remember. All right, but this number, does that make sense? But then if you knew what the standard deviation was, you would just go that number times the standard deviation. Does that make sense? Is that correct? All right, so now we got to talk about some standard deviations and some stuff. All right, so the confidence interval is always going to sort of follow like the same types of forms, right? So then this is the point estimate plus or minus the margin of error. And then this is the number of standard deviations. And this is the standard deviations value, right? Does that make sense? And then we're going to have different types of distributions. All right, so the first one that we could have is like normal. X bar is normal with mean, mu, and standard deviation sigma over square root of n. Actually, let me get rid of this. Let me make this bigger. All right, well, then we would use X bar. Actually, sorry, we don't. Yeah, we would use X bar, then plus or minus the number of standard deviations. We use Z alpha over 2. Then the standard deviation in this case would be sigma over square root of n. Does that make sense? Does that make sense? If you remember, we did this one also where X is binomial with parameters N and P. What was the mean when we do binomial? Yeah, so just N times P, right? What was the standard deviation? Square root of NPQ, good. Does that make sense? We're not going to do that one because they don't ask you that in this class, all right? The only reason why I'm talking about this one is because it's very closely related to P hat's distribution. P hat is really just the number of successes divided by N. Is that correct? But X is the number of successes when we do binomial. It's the same thing. Is that correct? So then P hat is this. Well, that means this, it turns out, is also like binomial, but we don't talk about this in this class. So there's a way you can actually start saying that this is normal. But it starts looking like a normal distribution, actually. But this is only in the cases when N times P and N times Q is greater than or equal to 5. In this book, I don't remember if it says 5 or 10, but 5 is the true answer. A lot of people say 10 because it gives you a better approximation, okay? But effectively, what any binomial distribution can act like a normal distribution if these two things are true. What is NP hat and NQ hat? What do those things mean? What is NP hat and NQ hat? What do those mean? What's P hat first? We just said it before. Yeah. What does it mean though? What did we say it was? Yeah. But what does it mean though? Like what is P again? Yeah, but proportion. Okay. Okay. Proportion of success. Same thing really though. Does that make sense? But they say proportion. Does that make sense? All right. The proportion of success, right? What was that? What did the hat mean again? So it's an estimate. Does that make sense? So P is the thing you want. P hat is estimating it. This we could is the estimated proportion. that make sense? Just like X bar is the estimate for mu. Does that make sense? Does that make sense? All right. But P hat is the estimated proportion. Okay, so it's a lot like P. Is that correct? What does this mean then? You think about it with numbers, it's very easy. Well, this is a proportion, right? We're multiplying that by n, right? What's going to happen if we take a percentage and we start multiplying it times n? We're going to get the percentage of that number. Is that correct? So if p hat is the proportions of success and n is the total number of numbers that are being involved, right? We're taking the percentage of the total number of numbers. That means we should find the number of successes in the sample. Does that make sense? If p hat is equal to x over n, then x is equal to n times p hat. Is that right? Is that right? So this is the number of successes in the sample. Is that correct? Does that make sense? What's this then? Okay, the number of not successes, failures, yeah. The number of, I like that. The number of not successes. You're correct though. So the number of failures. Does that make sense? Right? Whatever. We just always classifying things as success and failure in these cases. Does that make sense? So but do you get why? Like if you say that I don't think this is hard at all. Okay. This is just remembering fractions. This part. Does that make sense? So if n is 100, right? And then you say that there's, I don't know, 80 successes, right? Fine. P hat is 0.8. Is that correct? Q hat is 20 is correct, right? So then now if I did n times p hat, I mean, yeah, you should know how to do 80% of 100. Is that correct? It just sends you right back. Is that right? Does that make sense? So then, but I'm just saying, you do it with numbers, I guarantee you could have come up with it yourself. Does that make sense? Think of an example. Does that make sense? Question with this so far? Are we okay so far? All right. So X, the average was n times P. The standard deviation was this. Does that make sense? All I'm doing here for P hat is dividing by n, right? Well, guess what? We can take this and divide by n. We get P. If we take this and divide by n, I'm just going to write it separately for a second. Square root of npq divided by n is the same thing as root n times root pq over n. You could think of this as n to the power of 1/2 divided by n to the power of 1. Which is negative 1/2, which means it goes to the bottom. Or you could think of this as if you have square root of n over n, n could be thought of as square root of n times square root of n. Does that make sense? Then these two just cancel. Then you get this. But we get this either way. Does that make sense? So then this part could be rewritten as, put the n on the bottom. Does that make sense? So you get this formula. Does that make sense? Now the only problem is we're not going to actually have what P and Q are because we're going to be trying to estimate those. So we're gonna have to use the estimates here. Does that make sense? We're trying to figure out what P is the whole time. We don't know what that is. Is that right? So then this just becomes though this. Does that make sense? Divide by n and like goes to the bottom. Does that make sense? Does that make sense? All right, but then we have all the stuff to do our normal distribution. Now, all of a sudden now we have P hat plus or minus now Z alpha over 2. We already know how to find this from before. Is that correct? The confidence levels. Does that make sense? Because you have to tell me at the beginning how confident you want to be. Is that right? That's not something we like solve for. Does that make sense? Does that make sense? So they're going to say, I want you to give me a 90% confidence interval. I want you to get a 95% confidence interval, etc. Right? Now this part over here, this would now be just whatever the standard error of the mean is, or the standard deviation of the distribution, which is square root of P hat Q hat over N. Does that make sense? Does that make sense? There's going to be one other one we have to talk about, but I'm going to save it. I don't want to do it right now. Let's do an example. This just takes forever to go through this stuff. All right. There's only like one more major lecture that we really have to go through a bunch of crap with. All right. The rest of it's actually kind of done, believe it or not, for the whole year. All right. What is this garbage? All right. I'm going to go through these quickly because I want to get to the actual problem. Does that make sense? Find the critical value Z alpha over 2 that corresponds to a 98% confidence level. Okay, so we just draw 98%. Z alpha over 2 means like this and this is alpha. So that means that part's alpha over 2. Does that make sense? How much is alpha over 2 in this case? 1%. Then if I want to find out what this position is, because that's the position with 1% to its right, right? How do I figure out what that is? Beyonce. Yeah, that's why I'm drawing the picture. Does that make sense? So this position here is going to be what? Inv norm of 0.99. Is that correct? Again, draw the picture. Does that make sense? I'm not like doing this for fun. I can do it in my head. Okay. Does that make sense? I'm trying to force you to do it this way because I'm telling you it's easier. All right. What's the amount of area to the left of this position? 99, right? All right. What about this one? How do I calculate this one? Ninety-six. You had it wrong. So then this 0.35, this is 93.035, right? So then 96.5. Does that make sense? Any question with this? Should be easy. This is on your test for chapter 6 also anyway. So you should know it's on the homework. So you should know how to do it. Find the point estimate of the proportion of people who are wearing hearing aids in a random sample of 898, 46 people are wearing hearing aids. This one should be easy. 10. This one I think you should be able to do without taking this class. What do I do? I don't know what you mean. Yeah, it says proportion of successes. So 46 divided by 898. I don't think there's going to be an easier question that they're going to ask you. Does that make sense? Does that make sense, guys? Express the confidence interval in the form p hat plus or minus e. We did this the first day of class. How do I find the center of this thing? You take the average of these two. Is that correct? So this is just going to be 0.38 plus 0.54 divided by 2 for p hat. Is that right? How do I figure out what e is? E should be the distance between these two things divided by 2. Is that correct? So this is going to be 0.54 minus 0.38 divided by 2. Is that right? Should be. Margin of error. Does that make sense? Does that make sense, guys? All right, I'm not going to just find the margin of error here. We're going to do the whole thing. By the way, this is another thing that's going to be a complete joke to do on the calculator. Like very, very, very easy. Does everyone understand what I'm saying? Again, the problem is the interpretation. Because what does it mean? Does that make sense? But first, we're going to calculate it by hand, and then we're going to do it by the program. Does that make sense? Assume that a sample is used to estimate a population proportion P, find the margin of error E that corresponds to given statistics and the confidence level around your margin of error. Also, let's just say construct the confidence interval. Okery dokery. All right, so all they have here is a sample. Does that make sense? They have 1,510 people. They said of which 35% are successes. What does that mean 35% is? Sorry? Yeah. Not P though. It's not P. It's P hat. Does that make sense? Now, I think this is one of the questions that does this. No, it's not. Wait, yeah, I think it is actually. These numbers are always going to be they're going to be rounded. Does that make sense? Right? It shouldn't exactly be 35%. Is that correct? Necessarily. Does that make sense? Does that make sense? Because then like X should be equal to N times P hat. What is that in this case? Oh, let me get the other calculator actually. $528.5. Well, there's not 528.5 successes. There has to be 529. Does that make sense? They rounded it. Does that make sense? This number was rounded. So then this we had to round back. Does that make sense? All right. So there's actually 529 successes. Okay, whatever. I don't even know if we really even needed to bother with that much. All right. Now, but you have to understand it because it's going to come up and you're going to get confused otherwise. Alrighty. So now the thing is I said though that if N times P hat and N times Q hat are greater than or equal to 5, then we can start saying that this is sort of like normally distributed, all right? Effectively, the central limit theorem starts applying and stuff like that, but it starts becoming normally distributed. Does that make sense? So then n times q hat is what? What would that, how would you calculate that here? It has to just be 1510 minus this number. Does that make sense? If these are the number of successes, the number of failures has to be 1510 minus this. Is that right? What do you get? 9 what? 981. Does that make sense? Right? All right, great. Both these are greater than or equal to 5. That means it's normally distributed. So p hat is approximately normal with mean equal to, we're going to assume it's this because we don't have anything else to say. Then the standard deviation is square root of p hat q hat over n. Does that make sense? So that's 529 over 1510 times 981 over 1510, all divided by 1510. PQ over N. Does that make sense? Does that make sense? How do we determine the 90% confidence? How do we determine the right z-score for that? Draw what? What do you draw what? No. Five on each side. This is 90, right? That would have to be 5, and that would have to be 5. Is that correct? So how do I find how many standard deviations I would have to go from here to here? Inverse norm of 0.95. What is that number? Oh, wait, we just did this. 1.645. Is that correct? Does that make sense? Does that make sense? Therefore, the margin of error is equal to the number of standard deviations away times the value of the standard deviation, right? The number of standard deviations away is z alpha over 2. The value of the standard deviation is square root of p hat q hat over n. Is that correct? Z alpha over 2, we said what that was already. Inverse norm of 0.95. We said what all this garbage was. 529 over 1510. What is this? 981 over 1510 over 1510. All under the square root. Is that correct? How do we get the confidence interval? That is just the point estimate plus or minus the margin of error. What's the point estimate in this case? $35%. Does that make sense? That's what came from the sample. Is that right? Negative. What are you talking about? Huh? So wait, you're going to estimate a proportion of some sort of successes. It's going to be negative? I don't know what you're talking about. That don't make no sense. You got me? All right. So then, in other words, all I have to do is take 0.35 plus or minus whatever this stupid number is. Is that right? Is that right? So we just do this garbage on the calculator. So this is second dister inverse norm 0.95. Now we have to multiply this by the square root of whatever all this stuff was, right? Actually, I'm gonna write these out as two separate things, just so you can see all the calculations. All right, so inverse norm 0.95. That thing, right? We did this before a couple times already. Is that correct? Now, square root of P at Q hat over N, whatever. So this was 529 divided by 1510 times 1510 minus 529 all over 1510. And then we divided that again by 1510. Does that make sense? So we get this. Now, P hat is actually what? 529 divided by 1510, right? So now we need to do P hat plus or minus the margin of error. So first I'm going to calculate the margin of error. Does that make sense? But the margin of error is just the number of standard deviations away from the mean times the value of the standard deviation. Is that right? So then we get this thing times this thing. That's the margin of error. Does that make sense? That's the answer to the question. Does that make sense? Now, if we want to do the confidence interval means I have to take this plus this, right? And I have to do this minus this. Does that make sense? So now we end up getting that this is like approximately 0.35 plus or minus, what was this? 0.02019? 0.02019, something like that. Does that make sense? That means we ended up getting here. This was a lower number. This was the upper number, 0.3301. Point 37053. Does that make sense? That means we think that the population proportion is somewhere between 0.3301. So we say the 90% confidence interval for the population proportion are those things, either one. Does that make sense? Does that make sense? Question? All right, now I told you there's a really simple way to do this on the calculator, right? But again, if you don't understand this, you're not going to be able to do the next 3 chapters. Because it's all related to the exact same thing here. Does that make sense? Z-score, number of standard deviations away. Does that make sense? And then these particular areas. Does that make sense? You understand what it means, though? There's not really going to be very much more left to learn. Does that make sense? Okay. All right. So, how can we do this on La Calculadora? All right. Well, if we go to tests, we haven't gone to tests yet. You'll see that if you scroll down, excuse me, and you see it says 7 through B here. They all say interval, interval, int. Does everybody see that? Those all mean interval. Does that make sense? If you look up at the top here, they all say test, 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 test. Does that make sense? Hypothesis test is chapters 8 and 9. Confidence intervals is chapter 7, 8, and 9. Does that make sense? All right. They say the exact same crap. Z interval, T interval, 2 sample Z, 2 sample T, 1 prop Z, 2 prop Z. Z test, T test, 2 sample Z test, 2 sample T test, 1 prop Z, 2 prop Z. Says the same crap. Does that make sense? You're gonna make a mistake and pick the wrong one sometimes and then have no idea what to do. Does that make sense? But we're going to explain those other ones soon. All right. For now, we're not talking about anything with regard to 2 samples. Every single time it says 2 here, that has to do with chapter 9. We're not going to get there for a little bit. Does that make sense? So the only things we're ever going to talk about here are the ones that say 1 or Z, T, and 1 prop Z. Does that make sense? If you had to guess which one we're going to use right now, which one would you guess? They all say integral. That was a bad guess. I would have said this one because it says prop for proportion. But that's all it means. Does that make sense? So, but that's why they're putting it here, because it helps us remember which one to pick. Does that make sense? Okay, again, this is your toolbox. Does that make sense? You're gonna pick one of them because it's gonna give you the answer. Does that make sense? Now, if you sit there and you start like being silly with this stuff and not understanding what it means and just trying to start clicking on things, you're gonna see how bad it gets really quick. Does that make sense? There's 3 things there. All you have to do is be able to learn what 3 of them mean. Does that make sense? And then that's it. Because if you look at it, these say the exact same thing. This says 2 sample Z. Oh, that says Z. This says 2 sample T. That says T. This says 1 prop Z. This says 2 prop Z. So everything is just for 2 samples eventually. Does that make sense? Okay, we're only doing 1 sample right now. Does that make sense? Okay, great. We're going to pick 1 prop Z. Does everybody see that? XN. All right. Now I'm not helping anymore. You have to tell me what to type in here. So for this problem here, how would I figure out what to type in? Somehow it's very, 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 very obvious. Sorry, we need this though. What does X mean again? Oh, good boy.
Oh, okay, so I was wrong. I was like,
No, damn correct. Good. Usually people don't remember this stuff. But we said it earlier today, but good. I'm glad you remembered, honestly. All right. Number of successes is correct. Does that make sense? All right, but like they didn't explicitly give me the number of successes here. Is that right? What do you mean? That's not the number though. It's the percent. Is that correct? So how do I get the number again? Multiply. 35 times 1510. Right? What's n? What do you think this part is? 90. Wow. This was a toughie. Does that make sense? Now you could write 0.9 here or 90. Does that make sense? All right. Now, if I do this and then I push calculate, what happens? Oh, error. Piece of shit. Error. Armimity. What does this mean? It says error domain. Domain. What does that mean? Anybody remember? Math domain. It's the X values you plug into the function. Does that make sense? So this is saying there's something wrong with what I'm plugging in. Does that make sense? What's up? Sorry, say it one more time. Because there's a decimal. Calculator's trying to teach you again. Does that make sense? X has to be number of successes, right? If there's 1,510 people, there ain't 528.5 that voted for Trump. Does that make sense? There's 529er. Is that right? Does that make sense? All right, so you do this, you push enter. Holy God, I love the calculator. Oh, it just did the whole thing. Oh, that's nice. Thank you. Isn't that nice of them? Does that make sense? Does everybody see that? Literally it gave us the whole thing. Is that correct? Does that make sense? All right. Sorry? No. You could type it in the calculator, two numbers. All right. So then the this thing here, the plus like some of them are right here also. Right? Plus also the other number that I was writing is right there also. Does that make sense? Wait 1 second. So then this thing here. The problem is though that the question is asking here though originally for the margin of error. Does that make sense? Does that make sense? But this is what it gave me. It didn't give me the margin of error. How do I get the margin of error from this? No. They want the margin of error. How do I get the margin of error here? That's correct. That's correct. But I'm just saying, like, I don't want to go and do all the formula and all that stuff if I don't have to. And the calculator has sort of already given me the final answer here. Is that correct? So what I'm asking is how do I get the margin of error? Because I'd rather you guys use the calculator to calculate it because that was so much faster and easier. Does that make sense? So given this information, how do I get the margin of error? This part was the margin of error right here, but how do I get that number from here? Sorry? You could subtract p hat from one of these things, that would work. Does that make sense? Either that or just do this minus this divided by 2. Does that make sense? Because if these are the and they added the same amount to go this way and this way, does that make sense? Then this is the center or the midpoint. Is that correct? So how do I get the midpoint? You just take the average of the two things. Is that right? How do I find the margin of error? The margin of error would be half of that distance. Is that right? So this one minus this one divided by 2. Does that make sense? Does that make sense? Or this one minus this one. Does that make sense? Question? Were you able to type it in? X is this, N is that. That's it. Does that make sense? But the point is that you got to be able to identify what those things are in the question. And if you don't know what they mean, then it's still going to be hard. Does that make sense? Question with us though? Any question here? This was pretty damn easy to type this in the calculator though. Once I knew what the X and the N were. Does that make sense? Because they got to tell me the stupid level of confidence in the question. Is that right? Do you understand? All right. There is one part I haven't mentioned yet. So I just want to say that real quick because I have to say why you need to still listen to me a little bit next time. But the thing is like when this says 90%, 90% confidence interval does not mean there's a 90% chance that the number, the P is going to fall between here and here. That is not what it means. Does that make sense? We have to talk about this again at the beginning of next class and all that stuff. And we're going to spend a lot more time and we're going to calculate a bunch more confidence intervals. This is only literally the first one we've done. Does that make sense? We're going to keep doing this like every day from now on. All right. But the thing is that this is, so I just want to say, it is wrong to interpret this by saying there is a 90% chance that P falls between the upper and lower numbers. Okay? I have to say what the 90% actually means. Does that make sense? This is confusing. All right. Every time you get a sample, right? You're going to get a sample, then you're going to get a p hat. Does that make sense? Then there's another sample someone else is calculating, right? We're all trying to figure out how many people are going to favor Donald Trump or something like that, right? And then there's another sample. And then there's like my sample. But let's say my sample's bad. Does that make sense? All right. Then each one of these things is going to give you a confidence interval. Does that make sense? They all give you some interval. Is that correct? But I'm saying like mine's going to be bad. Because some of these are going to be bad. Is that correct? They can't all be good. Is that right? No matter what you do, you sample, you just end up getting some bad data. Is that correct? But then we think that the proportion is going to fall between these things each time, right? So what do I mean by bad? Bad means it doesn't fall between them. Does that make sense? Does that make sense? Right? I mean, we said on this one that we think P is going to fall between here and here. If this stupid number is bad, it might not. Does that make sense? Right? 35% of the people like Donald Trump. Okay, maybe. What if this was 100? Then we would get something close to 100 over here. Is that correct? Probably not right. Does that make sense? Okay, but some of these intervals are going to be good. Some of them are going to be bad. Does that make sense? So your author actually draws this chart. I think this is a very good way to explain it, to be honest. But let's say that the true mean is like here somewhere. Or proportion, whatever. Let's say the first confidence interval is like from there to there. Let's say the second confidence interval is like from there to there. Let's say the third confidence interval is like there to there. Let's say mine was like here to here. Does that make sense? Mine was bad. Does that make sense what I'm saying? You get what I mean by that? Okay. So then the thing is this one was like an error. Is that right? But the rest of them were good. Is that correct? All right. Now, we don't know what's going to happen with your sample. Any stupid thing could happen. Does that make sense? What the 90% means is that %90 of all confidence intervals that could be created using the critical z-score that we came up with, z alpha over 2. Does that make sense? Will contain the true population parameter. Does that make sense? Does that make sense? This one contained it. This one contained it. This one contained it. This one did. Is that right? 9 out of every 10 of these will. Does that make sense? You just don't know which sample you got. Maybe your sample is good. Maybe your sample is bad. We don't know. Got me? All right, let's end there. Okay. Sorry.